So here's our browse history class with two methods, push and pop. Now to solve the problem in the last video, we should add iteration support to this class. So we should add a few new methods that allow us to iterate over a history object without knowing its internal representation. For example, we can add three methods, next, current, and hasNext. The next method advances the current item. The current method returns the current item. And hasNext tells us if there are more items that we have to visit. With these three methods, we can write code like this. So here we have a while loop. That's another type of loop we have in Java. It takes a condition. As long as this condition is true, it will execute this code in this block. So we call the hasNext method and ask the history, hey, do you have more items that we have to visit? If this returns true, then we read the current item, store it over here. So that's going to be a string. We can print it on the terminal and then advance the current item. So with this structure, we don't know the internal representation of the history object. Whether it uses a list or an array or a stack, it doesn't matter. The hasNext method returns a Boolean, the current method returns a string, and the next method returns void. So we don't know what is that internal data structure. We're telling the history object, hey, give me another item, give me another item. So we keep asking that until there are no more items to visit. So this solves the problem in the last video, but we have a different problem here. This design violates the single responsibility principle because this class has two different responsibilities. It's responsible for history management using these two methods, push and pop, and it's also responsible for iteration using these three methods. So to follow the single responsibility principle, we should take out these three methods out of this class and put them somewhere else. So we can introduce a new class called Iterator, and this class knows how to iterate a browse history object. Now each class has a single responsibility. Beautiful. Now technically we need different types of iterators. For example, today we're using a list inside the browse history class. So we need a special iterator that knows how to iterate over a list object. Tomorrow we replace that list with an array. So we should create a new iterator that knows how to iterate over an array. So technically, this iterator should be an interface that determines the capabilities we need from a real or a concrete iterator. We can implement this interface in different classes. So we can have a list iterator that knows how to iterate a list and an array iterator that knows how to iterate an array. Now, to tie all this together, we need to add a new method in the browse history class that is called createIterator. The return type of this method is going to be the iterator interface, but inside this method will return a new instance of one of these types. So if currently we're using a list inside the browse history class, in the createIterator method will return a new instance of the list iterator class. If tomorrow we replace that list with an array, we'll change this method and return a new array iterator. Now here's the beauty of this design. The clients of this class don't know about this concrete iterator implementations. When they call the createIterator method, they get an iterator object, so they program to an interface. If tomorrow we change the internal representation of this class, we just modify this method to return a different kind of iterator. Our clients, like the main class, will not get affected. So the browse history class has a dependency to the iterator interface because this method returns an iterator object. And that is what we call the iterator pattern. Next, I'm going to show you how to implement this in code.